Welcome back. Let's continue section 3.8, the derivative for inverse function and logarithm, okay? So now I'm gonna introduce a derivative rule for inverse function. And here it says like this. So assume f is a function and it has its own domain I. And also f inverse exists and is not zero on I. Remember, when we're talking about the domain for the original function, it's going to become the range for the inverse function, right? Remember the interchange from the previous part. Then we know that the f inverse is differentiable on its domain, which is the range of the original function. And we also can have this conclusion here, guys, okay? The derivative of the inverse function evaluated at a specific value b equals 1 over f in the derivative of fx evaluated at the f inverse of b, okay? So again, the derivative of the inverse function evaluated at b equals the reciprocal of the derivative of the original function evaluated at f inverse of b, okay? And where is this result from? The idea actually is very easy to prove. So basically, we are using chain rule, okay? Knowing that if you apply f of f inverse, they're gonna always give us x, okay, guys? So this is another property about a function and its inverse. No matter you make a composite function of f inverse or f inverse of f, it will always give you x. So that's where this is from, okay? So when we have f of f inverse equals x, and then I take the derivative of x on both sides, okay? It's kind of like starting with implicit differentiation, okay? But really we take the derivative on both sides. And then on the right hand side we have 1. On the left hand side, this is notation, right? But you see that this is a composite function, this is the outside function, this is the inside function, right? So we're gonna use the spirit of chain rule. That is, take the derivative of the outside function with respect to the inside function, give us this part, and then multiply the derivative of its inside function, which is the derivative of f inverse, okay? So that's why if you divide it in these pieces, you're gonna have the derivative of f inverse equals the reciprocal of the derivative of f evaluated at its f inverse, okay? And when we substitute x with b, that's where this derivative will from, okay? So that's a very, very simple explanation for this rule, okay? So now let's try to talk about one example and then to see or verify this derivative rule, okay? So let's look at this. You see that fx equals x squared. In the first part, we talked about, well, if we do not have any restrictions, meaning if the domain is all real numbers, then f of x equals x squared does not have an inverse because it's not a one-to-one. However, right now, I set my domain equals x is greater than 0, okay? So the graph for this one is going to become into this part, okay? This part. And, okay, so you see that when we draw the, excuse me. So when we